Hello everyone, I am Mert Yıldız from Bilkent University. I am an industrial engineering student and currently taking Physics 101, and this is my project, Moment of Inertia. The objective of this experiment to calculate the moment of inertia and determine how the change in the amount of its variables affects the inertia. And in this experiment, I am using uniform circular motion system to calculate angular momentum, and by angular momentum I will be calculating moment of inertia. Angular momentum is the rotational equivalent of linear momentum and represents with cross product of radius and linear momentum. Moment of inertia. The moment of inertia of a rigid body is a quantity that determines the torque needed for a desired angular acceleration about a rotational axis. Moment of inertia sphere, which I will be using in this experiment, and it can be calculated by this equation 2/5 mr square. Moment of inertia calculation by using angular momentum. Angular momentum, which I said, can be represented with cross product of radius and linear momentum. And linear momentum is equal to mass times velocity, which means angular momentum is equal to mass times velocity times radius. If we divide and multiply this equation by radius, we can get in this equation mr square times velocity over radius, and we know that velocity over radius is equal to angular velocity, and mr square is equal to moment of inertia, the general equation of the moment of inertia. And we can get this equation: angular momentum is equal to moment of inertia times angular velocity, which I will be using to calculate the amount of moment of inertia. Equipments are ruler, chronometer, circular motion system, different spheres, calculator, weighing machine. In experiment 1, I have used the same sphere but stabilized in the different positions with different radiuses, which affect the moment of inertia. This is my experiment 1. This is 2. And this is 3. These are the results. As you can see, the mass is same because the object is same, but radius is changing, which leads to change in moment of inertia. I put these results in a graph, which can be represented with curve. I connect the data results and get this curve. And this line represents the radius of the sphere. By this experiment, I calculated the moment of inertia of the sphere. I have calculated the moment of inertia experimentally and theoretically, which gave me error code of 86%. This is a high amount of error, but these are the reasons. My object's shape is sphere, but the equation of the angular momentum does not made for the objects like sphere. Rotating system should have been a perfect circle and made a uniform circular motion. My system involves friction, which is not a uniform circular motion. The angular velocity is decreasing, and mismeasurement of time and radius. This is my experiment 2. In this experiment, I have used different masses, but I stabilize them in the same position. This is my experiment 1. This is 2. And this is 3. These are the results, which you can see the radius is same Angular velocity is changing because angular velocity does not affect the moment of inertia. The mass is increasing and the moment of inertia is increasing. I have put all these results in a graph and connect them in a straight line. The line represents the proportionality between moment of inertia and mass. Conclusion: in experiment 1, I have learned that moment of inertia it depends on the radius, and moment of inertia is proportional to radius square, and also calculated the moment of inertia of sphere object and gave me a big amount of error. In experiment 2, I have learned that moment of inertia depends on mass and it is proportional to mass. And this is my experiment. Thank you for watching.